Hello. All right. Thanks, everybody, for coming out. The title of my talk is Atomic Components, Managing Dynamic React Components Using Atomic Design. So just quick show of hands. Who here has heard of atomic design previously? Great. Awesome. Who's heard of React? Okay. All right. Who's heard of Redux and data management, Flux? Okay. Okay, great. All right. So this is going to assume some prior knowledge of how data is managed outside of just specific React parent-child type stuff. Going to assume a little bit of prior knowledge about Redux or Flux, just data cross-component communication via some sort of third party. However, atomic design, we'll be getting into. So my name is Joey. I'm a front-end developer at Balderdash. We are Node.js consultants and maintainers of Sails. That's my website. You can find me on the interwebs at Yejodido. It's just my name mixed up. All right, atomic design. So what is atomic design? It is a methodology for creating design systems. And the way this works is that it's broken up into 5 discrete levels. You have atoms, molecules, organisms, templates, and pages. This was designed by Brad Frost and Dave Olson. They have a little library to help you organize your project in atomic design called Pattern Lab, patternlab.io. And atomic design, it lends a context to interfaces. It's very client-facing. It helps take some sort of static mock-up, these components, or these small pieces, and allows you to put an additional layer on top of it, which might sound like bloat, but it provides a sort of focus that allows you to, with these descriptions, communicate more easily across a team or explain to your client exactly how this is going to work in a greater flow of things. Why do we need it? So anytime we come across some sort of some abstraction or conceptual bloat, we have to ask ourselves, is the return worth the investment, right? So in our case, I know as developers we like to maybe sometimes over-design our structures and our systems just because we feel like that's thorough. But when we already have something that's on a pretty flat, simple level, adding this can a lot of times bring a focus to it, an organization that doesn't quite exist. Well, it doesn't exist without it, right? So. Atomic design in this case helps chunk with these 5 components, helps create this artificial hierarchy of the components in a mental way. So how does it do this? Well, it breaks it down into 5 atomic levels. So on the left, we have a small atom, which get composed into molecules, which then into organisms, and then into templates, and then into actual pages. So with atoms and molecules and organisms, what is an atom, right? Well, an atom in our domain is something like an input element or a button element, just small, very low-level HTML elements. Molecules would be a group of these together. Let's say a search bar, right? We have an input field, and we have a button that works with that input field. Those together form some sort of UI togetherness concept in the UI that is, we wouldn't think of them separately, so we can think of those as as a molecule. Then we take it a step further, and we say, well, that search bar has a further context, usually in UI patterns, in some sort of maybe a header element or something like that. It can be anywhere. It can be in anywhere on the page, but it still is usually grouped into something that has a greater context, and that's where our organisms come in, at least in atomic design. So these are repeatable elements or groups of molecules that tell a story in the UI. And so here's an example of them, right? So at the top, we obviously have an atom. Underneath that, we have molecules. We just have some sort of text along with an input and the button together. Those three atoms form a molecule. Might be over-explaining this. I think this is pretty intuitive. Underneath that, we have an organism. We have a logo. We have some navigation links, and then we have the search bar together. And that's in traditional atomic design what's considered an organism. So outside of that, Brad Frost recommends that we break our chemistry analogy and we just completely pivot into templates because it, quote, makes more sense to our clients in a lot of way. The templates are just groups of organisms that are dedicated to a page level abstraction and can be moved around wireframe style. The pages would be the actual instances of those templates that are designed to be deliverables. So, yeah, okay, that's fantastic. It's great for documents, great for print, but we don't deal with that stuff anymore. We're in a post-document era. We, as React, are building user interfaces, not necessarily pages and style sheets. And we have one HTML document we're serving, not pages that match up one-to-one with these styles. Or just views tied to specific models. We have small components and groups of them that need to have their own information. It's a very, very pre-SPA idea. So React does have these very specific concerns, as I mentioned. We have these living, breathing, life cycle-driven components with these contextual stores that model our UI state anymore. It's not like we're just pulling anything out of a database anymore. The organism relates only to other organisms in the atomic metaphor, and that they coexist in visual space, right, along one another on the template or page. This says nothing about how they're going to talk to each other. It's simply a means of visual organization and grouping, and we have concerns about how we can actually make these things talk to one another when it comes to implementation. We lack that atomic principle. So can we solve that? Does atomic design work outside of print? Does it work outside of design? Can we, as React developers, use these same metaphors? Because they seem very useful, right? I mean, we start with a UI, we start with a mock-up, and then we chop it up and break it down and organize them, try to find something cool with our directory, and good way to put them together so we can get this like actual tangible feel with it. So this is great for that. How can we use it? Luckily, Pattern Lab is designed in a very FOSS manner. It's very flexible with naming and structure. It's brand new, right? A lot of stuff we're seeing in this space is new and open to change. There's no one right way to do it, and we think that's just fine. Name things as you please, and we'll leave the hair splitting out of things. Fantastic. All right, so let's rethink this. How are we going to do this? Well, so what I've done is we're gonna not break after organisms. We're not going to pivot to templates and pages. We're instead going to extend, keep with this ecological metaphor, and add two new levels, the ecosystem and the environment. So we'll go from atoms to molecules to organisms, ecosystems, and then into some sort of larger environment. And what these do, so we're also going to slightly modify the organism. There's a problem with the organism, I feel, where the organism is the top level and then it pivots. In atomic design, they say, okay, yeah, an organism can be either the header, the footer, these groups of molecules. I get that. We group these molecules. Or let's say we have a product grid. We have these repeating products, it's a repeatable container. That's also an organism. And it's like, okay, so we have something that, I understand the grouping inside the header, but we're also just going to leverage this organism because we want to pivot to templates to describe product grids also, which are fundamentally different as repeatable containers. Not a big fan. So I say let's keep the organism as repeatable container. That's fine. But now that we have these new concepts to leverage the ecosystem and environment, let's figure out if we can take the context of what would encompass some sort of header or footer and maybe, abstract it out. So you see where we can go with that. So where atomic design pivots towards client understanding with pages and templates, we need to pivot towards implementation while still retaining the usefulness of the visual metaphors. So with the ecosystems, we're going to see an example. So this is our fake social app. It's fantastic. It's great. It's just a mock-up that I put together. We have some sort of, hey, what's up? It's going to tell someone my status, some notifications or messages. Chat people on the right are buddies. We can see who's online, talk to them if we want. I have some other stuff in there, some posts, some comments on there. A lot of people like my stuff. It's cool. I have a lot of friends. Got a nice gallery in there showing some awesome pictures from JSConf, my profile image to let everyone know who I am and how I see myself. All right, so what we're going to do instead is that this is the environment. We're encapsulating the whole thing. Environments are going to be a little bit flexible because in a lot of times when we're not just building this, great little isolated UI that is super cool on Dribbble and moves inside and things change inside this little card container and stuff like that, we actually still are building product that might need to move from page to page. We need full pages. So this environment is going to represent this still same page level, or if you don't need that, if everything is just moving pieces inside of a static UI, just one page level, your environment is the application itself, be your app component. It's also important to have the, so it's good to have this outer shell, not even for like Flux or Redux or anything, because a lot of times if you have siblings, like UI siblings like the navbar or the content container, you still need a way to get that information from the navbar to that, so you can just pass it up and pass it down. And so you're good there. The environment still lends itself to there. So it is flexible in that way, but still very useful. Outside of that, I want you all to take a minute just to think. So we know we have this environment. We also have these ecosystems that are going to obviously be subjunks of this. We're going to break them up into contextual components, like I had mentioned before, the navbar or something like that, some sort of header or footer. So if you were to do this, given this, you guys have just heard this just now, take a moment to think about what you would imagine would be the ecosystems of this, right? And I'm going to show you in just a second of how I interpreted this, because a lot of these are just design decisions. So this is how I think the ecosystems would be. We have one on the right for the chat, we have one for the main profile, and then we have one that would maybe be a header or footer. So they should represent the major core container components and ideas the interface is trying to communicate. Also provides a nice isolated context for when you're trying to style. The three major ecosystems here, chat, header orientation, and profile. If you're using Redux for your data management, this is where I have to assume the prior knowledge. There's a thing called smart components, which, if you don't know Redux, the smart components are the container components that are going to not only hold dumb components to which you pass your state and props, but also communicate with your reducers and get the information you need to pass it down. They're kind of like the managers in the application. And this also lends itself really well to this ecosystem metaphor. This is where that manipulation is going to happen. Helps so we can still leverage these things, right? Because Abramoff came up with this smart and dumb. The dumbs will be your organisms and your molecules and atoms, and you just pass them down through it. And it's nice that this level of abstraction, this conceptual bloat still is able to map pretty well to things that are already out there, so we don't need to add another thing. It just kind of plugs right in because we're all thinking along the same path sort of thing with breaking these UIs up into new ways. So yeah, they're responsible for both handling the data and delegating the manipulated state. So notice that we still have one ecosystem that is significantly complex versus the other two. The main profile ecosystem, that could probably be broken down even further because I don't think we're ready to go to the organism level yet. So ecosystems as in nature can be nested. So we break it up both visually, and it allows us to have some sort of isolation for when we want to pass things around. And that way we could be like, hey, go run with this profile part of the ecosystem, and you go run with this, and then we'll just worry about connecting them later. Maybe even make it a dumb ecosystem. They don't have to be smart, right? Consider that one a dumb component, and then have the parent ecosystem, the larger one, the profile section, be the one that's going to handle all that. So you work on that, you work on that, and we'll figure it out later. So after that, we're going to break it down into organisms, right? The repeatable containers. Chat instances, each of which have a molecule that is, your name, your profile picture. The repeatable posts, inside of which could be a number of different things, right? I mean, they're just like cards. This one has a text. This one is information about who's following me. Two down, there's about some sub-information about what I added with my new gallery. Just repeatable elements. I think that's pretty straightforward. So how do we organize these, right? This is great. It's very useful to start thinking of these components in this just slightly abstracted way to kind of give them some sort of orthogonal context, if you will. But can we also use this to help us actually literally organize our components in our project? And the answer is yeah. So just a brief tour of how things used to be organized, right, in React in the beginning. Everybody we had a components folder, and we put them all in. It was cool. It was very cool because we were like, oh, these components are cool. This is a new idea, We weren't really organizing our directives like that and then John Papa came along and was like, hey, let's add an additional layer of context. Let's say, hey, you know what? If all these directives are going to be inside of a footer or a header, let's make a footer component. Let's make a footer folder or something and put all the directives that are associated with that in there. Same thing. So we started doing that with our React components. We said, okay, you know what? So I've got a header part and some header components. This is getting kind of big. Got a profile. I'm going to put all my profile components in there and a footer and put all my components in there. That's fine. That's kind of how we do it today. It's the most common way to organize all your components. But this, you still have to refer to, it still requires some sort of over-design, I guess, in a lot of ways. I mean, you have to do a lot of thinking about naming and namespacing and where you're going to put things and where you're going to call things, and that might not be too bad of an issue. But when you can instead go back to what we had, which is this idea of, okay, look, these are all components. Yeah, they fall into these ideas, but these ideas don't relate to the specific type of implementation for our application that we're going to use. They might, we might want to reuse them in other things, and they're now scoped to this, profile idea. Let's instead, let's go with something flat. This is going to be a molecule, no matter where it is. It's pretty clear. This is going to be an atom. It's pretty clear. So we can take what we had, just that components folder, and then make our 5 atomic folders, and just start, throwing our components in there as they match up with these atomic principles. So what's nice about that is that it helps when you're trying to refactor and you want to change things. A lot of times, if you want to consider something on an organism level smart, and that makes you want to change it to an ecosystem, instead of going up and then finding exactly where that was in the project previously and finding the name and finding the path for it, you just go up one level because everything's flat. And you change the name, and you just say, all right, there's a molecule there. Or okay, that's an ecosystem now. So that's a brief idea of what atomic components can help you with. We've used it in a few of our projects to really great success. Communicating with design, especially if design knows these things, you'd be surprised how quickly even non-technical managers can pick up on this type of thing. They will, they kind of go off on their own, and you know, when we first start doing this, you feel like you might have to handhold or something a little, but you'd be surprised. It's actually really intuitive. I'm hoping that, you know, when we did that little experiment with, you know, okay, you create your own ecosystem sort of thing, we all probably kind of broke it up into at least those few sections, right? Might not have been exactly that, might have been more, might have been a little less, but I think we all understand as, you know, front-end developers exactly how these UIs lend themselves. So to get started, I put a little boilerplate Atomic Components app up on GitHub. This is the app right here, these little peace signs. It's an environment holding 2 ecosystems, inside of which are 4 organisms, inside of which are molecules with 2 atoms. So it uses, you know, Webpack and SCSS modules and, you know, Redux and all the cool fun stuff, so you can just clone it and get started and play around with it. And hopefully find as much use in it as we have. I appreciate it. Thank you.